So good morning students, this is the second part of the video. So in our earlier video we have read about the common simple machines. 6 types were there: lever, screw, inclined plane, wheel and axle, pulley, okay, etc. And now we'll start with the lever. So as you know, the lever is a rigid bar or a rod that can move about a fixed support or a point, and the fixed point is called a fulcrum, and the example is a crowbar. So the object which is required to be lifted is called a load, and the force which we apply on that or to lift the load is the effort, as you can see from the picture. Okay, so the fixed point is called fulcrum. The thing or an object which is required to be lifted is called load, and the force which we apply, that is called an effort. Okay, so see, there are two ends of the lever. Okay, so the distance between the fulcrum and the point where we are applying force, that is called the effort arm, and the distance from fulcrum to the point where load is there, that is called load arm. Okay, so the principle of lever considers a load with a fulcrum at point, okay, and at one end the effort is applied which lifts the load at the other end of the rod. Okay, now I'll see the mechanical advantage of a lever. Since the lever amplifies or multiplies the force which we apply, the load is balanced by the effort, and as a result what happens, we can lift a bigger object or a heavier object. So here you can see load is multiplied with load arm and effort is multiplied with the effort arm. So the effort arm is bigger, so what happens, we have to apply the less effort in order to lift up the heavy load. So load by effort or effort, okay, so that depends upon the length of the effort arm and the load arm. So it can be greater than 1, equal to 1 or less than 1. Okay, now the common levers which we use in our daily life are hammers, scissors, nail clippers, etc. Okay, so levers are categorized into 3 classes: class 1 lever, class 2 lever and class 3 lever. So let's see the class 1 lever first. So in class 1 lever, as you can see, this is the example of a class 1 lever. Okay, so here what happens, the fulcrum is between the load and the effort. Okay, so it always changes the direction of the force and it applies the downward effort on the lever, and as a result the load is moved upwards. So it is always greater than or equal to or less than 1. In class 2 levers, the load is between the effort and fulcrum. Okay, so see here, it is a wheelbarrow and you can see the load is between the effort and the fulcrum. So what happens here, the effort arm is always longer than the load arm, so it is the mechanical advantage is always greater than. In class 3 lever, the effort is between the load and the fulcrum. So if you can see here from the example, this is a fishing rod. Okay, so here what happens, the effort arm is smaller than the load arm, so the mechanical advantage is always lesser than 1. So the examples of such levers are knife, tongs and fishing rod. Now let's move on to the next one, that is the inclined plane. What is an inclined plane? It's a sloping surface, okay, or a slanting surface, and here 2 points are connected, point 1 and point 2. So, and the points are at different heights, you can see. So what happens here, the objects can be moved up or down easily. So it reduces the effort, okay, needed to lift up heavy objects. So the mechanical advantage is the length of the inclined plane, or L by the vertical height, okay, H. So it is also a force multiplier, and the mechanical advantage is greater than 1. So a pulley is similar to a wheel and axle. So a pulley is a wheel with a grooved rim. So in center it is fixed to an axle, and the groove is used to, the rope is fixed, and in the center and it is used to move over the groove. So the wheel is also always free to move, and it is used to lift the heavy objects, okay, or moving a heavy objects. So there are several types of pulley: single fixed pulley and a moving pulley. So the pulley we use normally to draw the water from the well. So if you will see the structure, it is fixed to a support block, and there is axle in the center. Block is the frame, and from one side the load is lifted, and the other side the effort is applied. Okay, so when we have to lift heavy loads, then several pulley are used together. So the force needed to lift the load reduces, and such arrangement is called the block and tackle system. So the fixed pulley is attached to the hook of or a wall, and it doesn't move, and it only changes the direction of the force applied. So the mechanical advantage of this fixed pulley is 1. So whatever the load which is to be lifted, the same amount of force or the applied force should be equal to the weight of the load. So in a movable pulley, the pulley is not fixed on a support. You can see the one end of the rope is fixed to the support, and it passes around the pulley, and the effort is applied to the other free end. So the load doubles the applied effort, and means the whatever effort you will apply, the double of that weight can be lifted with the movable pulley. Now let's see the screw. So you can see this is the mouth of a jar, and it has grooves. So this is, so it is the another application of the inclined plane. So the thread of a screw is an inclined plane wrapped around the screw. Okay, so you can see in the jar the two terms which are associated are threads, lead and pitch. So the threads are the windings, as you can see, of the screw. The linear distance covered by the screw is 1 complete turn. That will be 360 degrees, and it is called its lead. And the pitch is the distance between the two adjacent threads. So the mechanical advantage of the screw is determined by the lead. The smaller the lead will be, the higher will be the mechanical advantage. So it is also a force multiplier, as it takes less effort to insert a screw when we insert it in a piece of wood compared to the nail. Okay, so the things will be interlocked in such a way that they cannot be forced to get apart, and so it acts as a fastener. Okay, you can see the caps of the jars and the bottles. Okay, so this is the screw. Next is the wheel axle arrangement. So it has a wheel, as you can see, and attached to a cylindrical rod. Okay, so this is called axle and this is called wheel. So it is also a simple machine. So when you apply the force to this wheel, it helps in turning the axle. Okay, so this kind of arrangement is used as a force multiplier, like in a doorknob. Okay, or you can say in a bicycle, or it acts as a speed multiplier. You see here. Okay, the steering wheel in a car is also an example of a wheel and axle arrangement. The mechanical advantage of this wheel and axle is the ratio of the radius of the wheel and to the radius of the axle. Okay. So a wedge is similar to the pair of inclined planes. So you can say that by application of inclined planes, it is an application with which it moves. So if you will see, it is a simple machine made up of wood or metal, and it has two slanting sides ending in a sharp pointed edge. Okay, as you can see in this X, and it is a generally combination of two inclined planes. So we use the wedge like X to split objects. The sharper the wedge will be, the easier is to pierce the object. Why? Because the sharper edge reduces the surface area and the small force results in more pressure. We have already discussed the functioning of the machine in the first video. So we'll see the care of the machine. So a machine also needs to be properly cared of and maintained. So we need to care for the machines. Why? Because they help us in performing our tasks and makes it easy. So when we'll care for them, so they will have a long life. Okay. So there are some methods to care for the machine, like we should cover the machine when we are not using them. Then we have to keep the machine in the clean places so that they are away from the dirt and moisture. And why we should do that? Because moisture causes rusting. So we can paint the surfaces of the machine. Okay. And the third is we can also apply the oil or the grease so that the friction is reduced and it avoids also the wear and tear of the machine. Now for the classwork, you will do the stop and reflect of page number 69, okay, and page number 66. And for the homework, you will do B prompt book exercise question number A, B and C by your own self. Okay.